or next class.
Okay, sure. Yeah, I forgot yesterday. Today, after the class, you remind me. I'll immediately send it.
Okay, okay, sir.
Hmm. Okay, so we have discussed till the implementation of virtual functions, and we also discussed about in our last class the concept of pure virtual function, where the definition is not known at that moment, but the interface is known. So if the base class feels that this interface should be there in all the specialized classes that is inherited from it, so that is possible. We can specify the name of the interface and the prototype of it, but it may not specify, it may not need to define the details of the function body. So this is possible, and so in that case, because the definition of that class is incomplete, we call it as an abstract base class. And the way to specify that incompleteness is you write the function name equal to 0 colon uh, 0 semicolon. So that is how we write it. And in such a situation, if we still want some incomplete definition, so if the definition is unknown, that is possible. And if the definition is incompletely known, then even though we do this, we can define that partial, give that partial definition, which does not mean that you have completed uh, this the definition of this base class. So this base class still remains abstract, because this is in any way it's a incomplete definition, and it still uh, considers this function to be a pure virtual function. So we say that it's pure virtual function with some incomplete definitions. And we also found that how a generic pointer of the topmost base class can point or refer to uh, the different objects of the classes derived from it. And so that is how we can have a uniform or a generalized container uh, array or a container object, and that is in many cases useful. And the call to those virtual functions is anyway polymorphic. So we have found how the polymorphic hierarchies can be implemented, how the virtual keyword can be implemented, and how the abstract base class and the pure virtual function also sometimes it is useful. So till now, whatever we have discussed, so it is these topics are a kind of extension of the inheritance. So inheritance, once we accept that inheritance is possible, and it uh, helps the designer or the coder to go for code reuse. Now, during inheritance, you read what are the modes of inheritance: public, private, protected. The protected mode was introduced, and all those details were there. And we basically, I think you focused on how to construct a derived object, which will have a base portion, how we pass the arguments to the constructor of the base, what is the order in which the derived constructor, the corresponding base constructors will be called, and the destructors will be called. So all those details we focused. And then it was all about some more details of how to handle the ambiguities and all. But still there is one more topic related to inheritance that is left in terms of so in most of the cases the kind of inheritance structure that we dealt with was something like this. It has got a specific common feature where a particular derived class is derived from a single base class. So that's a kind of commonality in all these three. So a derived class is or inherits properties from a single base class. And this is a key point to note. So all these three examples actually follow that particular constant, you can say, or that is what you observe here. But there can be some cases where we have this situation, and now we deviate from that what you observe, and we see that this faculty room. So the example, I think in some other classes Deepanita has explained this. I'm not going into the details. So this is a room. It's a normal general room, and the lab room is a special kind of room which has got uh, PCs, desktop PCs, and servers, and all this, mostly chairs, tables, and all. And a lab room can be also considered to be a research lab room, where instead of just having desktops, you have got workstations and you have got cubicles for the research scholars or PhD scholars to sit. So it has got some additional features, and probably it will have a shared printer and all this for their use, and they will have their own say drawers and all this. So in the multiple inheritance, what happens now? A project research lab. So this is something, a specialized project lab we can think of. Say I have got a research lab. So a general research lab means all the PhD students sit. Now in a project research lab, it is somewhat related to a particular faculty or a couple of faculties. Say two of us, we are having some projects, and we are having that projects, all the students and all the project equipments in one particular research room, and we say it's a project research lab room. So this means, so BTech students who are doing intern, they can work there. Then the PhD students under my project also can work there. So it has got the, and then the thing is, maybe uh, we don't have too much of space in our department. So my official room, my office, I convert it to a research lab. So the thing is, I know the, so when I convert my, so the thing is, this one will have the facilities that where a faculty can sit with his own desk and all. So all the facilities of a faculty room, and also all the facilities of a research lab room. So that way we can think of that a project research lab room, it can be inherited from the properties of a faculty room, and then also it will inherit some properties from the research lab room. Okay, so we can upgrade that, and we can have uh, if you think of this. So this research lab room, we already found that research lab room uh, can be inherited from the lab room like this. So if you think of it, that it has got inherited from the lab room, so it has got something like this. So still that observation holds, that this subclass or the derived class D, it inherits properties from both B and C base classes. Okay, so which was not present here, here, or here. And in the extreme case, what we can think, what we can consider is something like this. So we take a different domain of example, where it is a landline phone. A landline phone, it was there. Now gradually, so when you're talking about phones, so earlier we just knew about landline phones in the mid 80s, or in the maybe in the early 90s also. Now then, those landline phones were then upgraded to speaker phones. So now you have got speakers and all this, and those are having some additional features. So a speaker phone is a land phone. And those days, even in the late 80s, we used to have the cordless phones. So cordless means you have got a fixed receiver kind of thing, but there's a cordless say unit which you can carry and roam around in your entire apartment. Okay, so you do not have to, so it was not mobile, but it is within a certain periphery of that handset, the that device, the that receiver unit, you can carry on. So it is a kind of cordless phone. And then maybe this, and the speaker phone was there. So combining these two features, people came up with the mobile phone. Definitely the technology, the physical technology or the communication technology is different, because these are all cellular phones. These are all like landline, means public switch transport network and all this. But in terms of the phone features, if you can see, the mobile phones are having this cordless, means you don't have to have a cord or a wire attached to it, and it has got speakers and all, and it is overall, it has got the phone feature. So if you say it's a kind of phone, so it is like this. So what I mean to say is, now the speaker phone and the cordless phone, these are derived classes which we over time, those are inherited from this land, from this phone. And what kind of features a general phone, any phone will have, you can have, you can think of, there will be some dialing pads, I mean uh, or buttons which, through which you can dial. So dialing facility, you can have the facility to receive. So few of these should be there, right? And there may be a small memory which you can use to redial. Redial means the last call that you have dialed, you can redial it like that. But these days in the mobile phone, you can browse through the last say maybe 20, or maybe all of them, you can store it in memory. You can browse and you can redial that part. So there are many things common. We are not going to the details, but let's focus on the structure, that these three are some specific type. Here we have got in both the three of this, there are examples where a particular derived class gets properties inherited from more than one base classes up above the hierarchy. So these are examples of where such things lie. So these are examples of multiple inheritance. Okay. So till now we have talked about the details, implementation, the issues, the ambiguities, and all the kind of problems related to single inheritance, or maybe in multiple levels like this, but it is just inheritance is from a single base class. But now if we go for multiple inheritance, let us see that what might be the probable challenges or issues that we need to deal with during implementation. So one concrete example can be the dean class, right? So the dean class, if we think of a faculty class, so in a typical uh, academic institute like ours, we have got a faculty class. So faculties, they take classes. So they are supposed to take only classes mostly, and they have got some administrative, some academic kind of loads, but that is purely they are meant for doing academic activities. But there are administrative staffs or administrative officers who are mainly dealing with non-academic activities. So these are academic activities and these are non-academic activities, like managing the hostels. So these are non-academic activities, right? Then managing the staff, like the normal staff, office staff and all this, managing the finance, managing the audits and all this, managing the construction work, managing the medical units and all. So they are non-academic activities. Now when you think of deans, so deans typically they are the posts. So deans are faculties, primarily deans are faculty. So dean class, when you try to define who is a dean, what are his activities, what are his functions or attributes. So deans in a institute like ours, I mean in all universities, it is like dean is a faculty, but a faculty who is also given the responsibility, some responsibility related to the administrative work of the organization or the institute. So definitely this dean will have to share, or will have to have uh, activities related to the administrative profile also. Okay. So organizing meetings, non-academic meetings and all, but also have to take classes. So if you think of implementing a dean class, and in fact in our institute, it was long back, like more than 15-16 years back, it was regional engineering college. So it was purely an engineering college, it was not a university under the Bardwan University it was affiliated. So those days there were no dean concept, because the deans were in the Bardwan University itself, because it was under that university. And we used to have only faculty in charge, or sometimes the HODs just they could try to communicate with them. But once it became the deemed university, then new dean posts need to be created, because it was going to be a deemed university. Now once it is there, so if you think of, there was a software which maintained the activities, the payroll and everything, all the details. So once this REC got converted to NIT, sorry, so in the software you need to define a new class called dean class. Now it becomes a university. Now whenever you create a dean class, now you know that we have got, so instead of writing the features and the attributes and the activities or the behavior of the dean class afresh, you can try to inherit it from these two. So you say that dean is a faculty, or and dean, and also dean is a administrative officer. So these are concrete examples. Now once we try to implement this, what do I write? Say class, say class faculty was there. Okay, so these details I'm not writing. And then I have got class admin, and so these two are already there, say for example. Now if I would like to create this dean class, so class dean, so what should be the syntax? What do you think? Dean class should be inherited, as we decided, from this faculty class and admin class in a public mode, say for example. So what should be the syntax of writing this? Hello?
That's public class faculty, comma, public class admin.
Public, which class? Public faculty,
Comma,
so,
public admin.
so comma public. So this is the simple syntax. So those who have not used this, so this is very simple to know. Okay. So you can have many such cases. I mean, instead of just two, you can have inherited, the new class may be inherited from multiple such classes, say A, B, C, D, and this X is inherited like this. So if you have that, so you can write class X, then public A, comma public B, comma public C, like this. You can keep on doing that, and public D. Okay, that means this particular class is getting inherited publicly from I mean taking the features and behavior from A, B, C, D, like this. So it's something like the son or daughter inherits features and behaviors from his father and also mother, like this. Okay, and it is not necessary that he will acquire everything intact. Now during the inheritance process, he is free to modify some of them, he is free to uh, ignore some of them. I mean, he just don't update some of the features that he inherits. Sometimes he updates the one that he inherits, and sometimes he adds some new of his own, like that. So as in real life this is common. As I mentioned, the son or daughter inherits features and properties from the parent and from both the parents, father and mother. In this real case also the same thing happen. In this programming case also the same thing might happen. Okay. Now, so these are easy. So syntax is easy. Now can you find out what kind of issues might occur in doing so? If we allow this multiple inheritance to be implemented, what might be the issues that you may need to face? And that is pretty easy to figure out intuitively. You don't need any prior knowledge of C++. Can you figure out that what might be the problem?
Sir, there may be a multiple copy of a data type that might be possible.
See, for example, say father and mother. Maybe the father is having a curly hair, and mother is having some different kind of hair pattern, or maybe brown hair and mother is having black hair. So if that is the hairstyle, or I mean the hair color, maybe genetically they have inherited and they are having that. So when the son is born, what do you think? I mean, what hair color he should get? I mean, I'm not. Yeah, I'm ignoring the genetics of it, the genetics and the dominant and the recessive and all these genes and all this. I'm not focusing on that. But the thing is, now when you say that, what should I assign, or when I say hair color of the son, so which one should I use? Because hair color is a feature that is there, uh, defined in both the parents, father and mother, right? So we say that hair color is one feature, one attribute. So this is here, this is here. Now when the sun, so sun knows that okay, I also will have a hair color. So the thing is, it says that let this feature be inherited. Now it will inherit. So the thing is, it has got the same. So might be that the same name has been used. You see. So the father's class also somebody has written, some other software designer has implemented this father class and he has defined it as hair color, and the mother's class also defined by some others and like this. So if both gets inherited, when you are dealing with the son, so what is the problem? The thing is, if you here try to refer to hair color, so which particular, because both are inherited here in the son class, so which one you are referring to? Can you unambiguously say which one you are referring to? Hello? If you create a son object x and if you write x dot hair color, because both are inherited, you have not explicitly mentioned it. So x dot hair color, so whose hair color it will uh, display? Is that clear? Yeah, I mean, is that obvious, or is that uh, can it be determined by the compiler?
No, sir.
And you might say that why you are trying to give the same names here. Okay, I know the hair color, so you might have called it as uh, h color, like that. So then it resolves. So if you write hair color, it means you are trying to get the father's hair color. If it is h color, if it is the mother's hair color. But the thing is, you don't know, because this class might have been implemented, the design by some other person in that organization xyz, and this class might have been designed by some other employee, because these two are independent. So they have been implemented in say maybe a couple of years back by two different persons, and they really don't know. They both found that okay, hair color h color is a good variable name, but when later point of time some other employee, he was asked to modify this class design and come up with a class derived class son with the definition of a son. So you are given with the class design and he found that okay, I can just derive it from these two existing ones. Now he found that this problem occurs. Okay, so can we resolve it, or what do I do? I mean, what happens if such ambiguities arise? Are you getting the problem? Everybody got the problem? Hello?
Sir, we can use virtual base class, I think.
Which one? Virtual?
Base class.
Virtual base class.
Hmm.
What does it mean? I mean, are you just trying to guess something? I mean, that's fine. I mean, you may not have the right answer. I'm not seeking also. But the thing is, you say because virtual keyword played some trick earlier also, so might be that we say it's virtual, right? Is that what you
No,
say?
sir, it is a bit different. Um,
So, what do you mean by virtual base class? So virtual function we
Sir,
know.
I
What
think
would be the virtual base class? What way it should help us, and what should be the features of it?
Sir, I think while defining the class Sun, we can define it by saying class Sun colon and virtual public father comma virtual public
No,
mother.
I mean, is that required here? Is that required? I mean, yeah, this is a concept, but this is not applicable here. This is not the situation where we need to declare inheriting the son class virtually from father and mother. This is not the case.
Okay.
That is for a different for a different problem. So you may
Okay.
not have the solution. So because I'll be discussing it. But the thing is, first of all, have you got the issue? Have you got the problem? What we are dealing with? Once we jump into multiple inheritance, and which is quite obvious in the design. So are you aware of the problem that you are creating out of it?
Yes, sir.
Well, so I think everybody can appreciate the problem that is there, and you have to find out some options how to how the compiler will resolve it and all this, right? So one step ahead, I mean something like this. So your, what do I say? Maybe in the faculty case, if you write faculty admin and you have got dean, but you see both of them are employees, right? This faculty and dean might be that before, I mean, it was a later point of time, but prior to that, faculty was there and the admin class was there, and then even prior to that, there was an employee class, right? So when you are trying to design a database management system, or I mean a database of all the entities in a academic institution, you create an employee class, you create a student class, you create maybe some other classes also. So basically faculty is an employee and admin is also an employee. And then maybe during the REC days, this was fine to have up to this much. Now once we started in the NIT era, we have added this dean. So now when it was only this much, that means we have to deal with this multiple inheritance issue, right? Sorry, it is a normal case. It was a normal, faculty is inheriting from the employee, admin is inheriting from the employee. But once we have the NIT and we have created a dean out of inheriting both of these properties, so now you see this is a case of multiple inheritance because of this case. So this is, if you focus on this part, it is multiple inheritance, but it is not only of that type. You have got some other issue also, like this employee. So this part is also there. So once you have this kind of structure, so what happens when you say create a dean? If you have created, say, I create a dean object. See, dean is a derived object. So in this dean object, what it should comprise of? Say this part is the employee object. So this blue part is an employee object. Okay. And this faculty is a green object. It has got a green part. And uh, this admin is a red one. Okay. And this dean, it may be a black one. Okay. So this faculty is derived from this employee. So definitely this faculty will have some portion of this object, right? And this admin also will have some portion of this. Do you agree with this? Employee is this color, faculty is, one is the green, one is the red. So within the green portion, green object, we will have some portion of the base, right? And within this admin also you will have, within the red you have some portion of this. Do you agree with this?
Yes, sir.
Now the dean, let us assume the color to represent the dean object is this black. So dean object will comprise of which one? First of all, dean object will comprise of a faculty portion and the admin portion. So let us assume that it has got admin portion, and it will have faculty portion. Class. Okay, and within each of these two, you will have the portion of the, you can say this particular base, the topmost base. Okay, and then it will have its own portion, the black portion, right? Is that okay?
Yes, sir.
So now if I, okay, let me just complete the coloring. So do you agree that our real dean object will look like this, the coloring of that? So coloring is just to represent the distinction between which portion is belonging to which particular class. So do you agree with this? So if we call it as D, and if we call it as F, object of that type, if we call it as A, and if we call it as E, okay, so these are the name of the objects created. Now if I have an employee pointer, say P, so I call it as BP. Why I call BP? Because it's a, you see, there is a base class, right? It's a base of all of these classes. So if I've got an employee class of BP, and if I would like to store the address of D, is that possible? Can you have this? Hello? I have got BP, a pointer of this particular class, but I want this pointer to point to this particular object. Is that possible? Can BP point to A and F?
Yes, sir.
Yes, sir.
Yes, sir. It can
And
point.
can BP point to D? Are you not sure, or what conflict arises? I mean, it can, it's a base pointer. So a base pointer can point to any derived object belonging to that hierarchy, right? Which is towards, I mean, which has been derived from it. So base pointer can point to this, can this, and it can point to this also, right? And what is the feature called if it points to that? That this assignment is called
Upcasting.
upcasting. So upcasting is supported if you assign the address of A to BP, F to BP, and also D to BP. So do you agree with this? So this will be allowed. So, so this will be allowed. Do you have any other doubts that this will be allowed?
No, sir.
Hello?
No, sir. No.
So if this is not the case, then through that BP, if I would like to refer to, so through the BP, which colors I can refer? There are black, green, blue, and red. So which colored portions or which portions of the object layout I can actually refer to?
Blue, sir.
Blue, sir.
Hello?
Blue.
Is it only blue, or it can be any other colors also?
Sir, only blue.
Only blue. Why? Because that we already know that BP is, again, let us go back to that original example that I'm talking. BP is a director PA. So the director PA only knows the attributes of the director and nothing beyond that. But you can, if you want the director PA can store the address of a dean, address of a dean, and try to play a role of a dean PA, and also like that. So here this BP, because it is in this level, and in this level only this color is present, so it can refer to this blue portions only. So if I write here, you see, say, so this blue means there will be some definite name, but let us just write. So BP can refer to only the blue portion. So if I write the blue, so which blue portion it will refer? Which blue portion do you think it should refer? What are the blue portions? You have the blue portions here, and you have the blue portions here, right? So then which one should it refer? Do you have any question? Do you have any conclusion? Are you getting my point? Hello?
Yes, sir.
So is it straightforward, or is it ambiguous case for a compiler to resolve?
It's ambiguous, sir.
It is ambiguous, right? And if you have, you see, if you have got some other, so the thing is, by name also you don't know what to do. So this is a kind of ambiguity that arises. Okay, so in case of this kind of structure, we call this structure as a diamond structure. It's very much looks like a diamond, and that is quite obvious. So this is a inheritance. The structure, it's more looking like a diamond, right? And this is often called or referred to as a diamond problem. And this is some kind of extreme example of multiple inheritance. So it is not only multiple inheritance like this, but it is also multiple inheritance along with this combined together, it becomes a diamond. And this diamond shape creates many other ambiguous scenarios, and it's a kind of problem that need to be resolved before you allow multiple inheritance to be implemented, designed and implemented, right? So this diamond problem means which one should you refer, so you have to specify that. Okay, and in fact, when you create a diamond, so when you have a diamond, got a diamond type of pattern, do you really want something like this? Or you see, let me have something like this. I have to create a red, a black box representing the object, and which will have some kind of black portion which is exclusive to the derived this Dean class, and I must have a green portion. That's true. Sorry, I must have the green portion, and I must have the red portion also. But I must have, so there is no point of having two ambiguous instances of blue. I should have a single blue portion of it, right? So in other words, I would probably, so which one should I opt for, this or this? When I construct an object D, so which kind of object layout I would probably prefer to avoid any kind of ambiguity arising out of this diamond shaped design, object oriented design? The first one or the second one?
The second one.
Right, so this, it's obvious because we just now felt the problem that how it occurred when you are trying to use the base, say, see, if you are using D directly, then probably that is not, so even in that case also the problem occurs. So if this blue color is name is blue, so D dot blue means which blue you don't know, because either this blue or this blue. So definitely to avoid the ambiguity, we must construct the black object in this form, in the second form rather than the first form, right? So that these problems are eliminated. So one problem, like in the multiple inheritance, the basic problem is if both the base classes, which probably was designed and written or implemented by two different, just a minute. হ্যাঁ বিদেশ আমি ক্লাস নিচ্ছি একটু পরে কথা বলছি তোমার সাথে। হ্যাঁ okay, so if these two, see the problem, these two are defined by two different persons, and that's why they are not aware that what is your name and what this person is giving the name, and that's why there might be a name clash, the same name. And if there is a name clash, if the derived class object refers to that name which is common in both of these two, then the compiler says that I can't resolve it because which one you are trying to refer, I don't know, right? Because in this case also, if you look into the layout, you will have similar issue. Okay, so if this is the case, and if this father's hair color, say it's a red hair color, and the mother's hair color is maybe a blue hair color, okay, then when you construct the son, which is supposed to have some other attributes apart from hair color, so black attributes apart from hair color, so it will have, say this, so in fact, okay, so this, I think instead of using a different color, I should use the same color. So both variable names same means both are red. Now I say when I create this, you see, when I create the son object, the son object creates the portion of this mother, so this is corresponding to the mother, and this corresponding to the father. And when you actually refer to this hair color, so it does not know, because it has got both these red components, so it does not know which one you would like to pick up. So I think you got the basic problem that arises due to multiple inheritance, and specifically due to this diamond shaped design. Okay, so the one I cannot see the name, so the one that you are telling that I should use the keyword virtual, where
Yes, sir.
maybe here, so that is
Yes,
related
sir.
to solving this problem. Okay, so using, or when you are deriving this base class, say maybe the dean base class, the dean derived class from this faculty and admin, or this faculty, so you basically do it in a so you say it's virtual, so faculty is inherited virtually from the employee, and there's like that. So the virtual keyword comes in solving that part, but not in this case. Okay, but I think all of you got the problem, so that is important that you are convinced that there is a problem and we got the problem. Now the solution is very trivial to find out, and we should see how the syntax, what syntax we use and how it resolves. So let's get into the details of it. So we can just skip through these slides because we all explained. So this is one example where dean is inherited from admin, officer, faculty, and the parent. So dean is a person who is a parent, plays the role of a parent, faculty, and admin. And this is the syntax that we already mentioned. So public, so public. So we are publicly inheriting the dean from all the three. Now you have the option also that maybe you inherit dean from by inheriting publicly the properties of admin officer and faculty, and private maybe protectedly from the parent or something like that. So the design can be so those options also can be there. There is another example of the teaching assistant, just to see that what other problems also might have similar designs. So teaching assistant are I don't know, maybe that you people have never encountered teaching assistants in your sessionals, but teaching assistants are PhD scholars. Okay, so these are students or scholars, PhD scholars, who assist the faculty in taking the sessional classes, in conducting the sessional classes. Okay, so faculty, so they are not faculties, but they play the role of faculties during a sessional class. Okay, so teaching assistant in that sense, he or she plays the role of a faculty also, because he explains things, sometimes he takes tutorials also, but he's not a faculty. but he has got some attributes of a faculty, and he has got some attributes of a student also, because he has got enrollment numbers and he has got registration numbers. He's he performs registration in every semester, so like that. So this TA can be like this. Another example from the programming domain is IOStream. IOStream is a class. We know all that hash include IOStream. We all do that. But IOStream is inherited from the O stream and I stream, the output stream and the input stream. And this is also an example of multiple inheritance. And so this may be there may be that more than one totally orthogonal base class. So this is important. This orthogonal keyword is important. Totally orthogonal base class hierarchy. There may be more than one orthogonal base class hierarchy from which a class may be derived simultaneously. And this multiple inheritance has a sensitive issue, as we just now mentioned, due to its implementation, complexity and ambiguities. So one example is that of the diamond problem, diamond shape. The biggest problem with multiple inheritances involves the inheritance of variables or methods with duplicate names. I mean the same names used here and here from two or more base classes. And the question is which variables or methods should be chosen as the inherited in the inherited entities. Okay, so this we just now explained. So let us see this case. So this was the case of the diamond problem. So this example we have already illustrated. Now this IO stream, probably some of you are aware of the class IOS. IOS means input output stream class. So this is the topmost base class from which the I stream and the O stream got inherited, and then IO stream is inherited from both of these two. Okay. So there are many such examples of diamond hierarchy where the design inherently it falls in that type of hierarchy. And here again, this you see class IOS, it's a root based class. Class O stream inherited from publicly from IOS base class. Class I stream inherited publicly from IOS, and class IO stream inherited publicly from O stream and I stream. So implementation is fairly simple. I mean how we implement this hierarchical structure. But the problem is the multiple inheritance is a class may be inherited from two base classes, which in turn may be inherited from a common base class. So this is where the problem arises and the structure arises, creating a diamond hierarchy because of the shape of the class inheritance diagram in the situation. And what exactly is the problem? In the diamond problem, there are ambiguities that arises when two classes D1 and D2 inherit from the base class, and class D inherits from both of these two. So this is just what we meant. And there will be two sub-objects due to D1 and D2, as you can see here, of type base when D3 is constructed. So when D3 is constructed, you will have this part, and both will have this base part, you see. So that is what it shows, and we have also found. So we have just used some colors to represent that in that previous discussion. So in such a case, if you go for upcasting, then which base instance will be referred? So this is the issue. And also, if there is a method in the base class that D1, D2 have overridden, you see, say if there is a function method, say fx here in the base class, and say, so here it writes at base fx. Okay, it gives a comment like this. I mean the displays this in this prompt. Now if this D2 says that I would like to modify or override this with D2.fx, but this D1 says that I would like to, because anyway this is inherited, but when it is inherited, this says that we'll update it, we'll override it. So it says D1.fx. Okay, so if these two happens, and then say both gets inherited here in the D3, but D3 says that I am not going to override, I'll just accept it. So now it has got two copies of fx and fx. So one fx is this one, another fx is from this one. Okay, so then the problem is which one it should refer. So if it invokes, so if the object corresponding to D3 invokes, so So the problem is both are fx, and if D3 does not overwrite it, then it has inherited both the functions with the same signature and all. So this becomes ambiguous. So which method which will invoke? Okay. So C++ resolves the diamond problem using virtual inheritance. So earlier we have used the keyword virtual many a times, and it is almost like 3-4 situations we have used the keyword virtual to resolve the problem, right? What are they? What are they? The virtual function, then the virtual function, pure virtual function, like that. And now we say that it is virtual inheritance. So the inheritance becomes virtual. Any question till this point? Okay. So these are all pretty simple. So in case of multiple inheritance, the semantics are pretty simple and obvious. Data members in the derived class inherits all the data members of all the base classes. You see. So this is an important point to know. So the even in this case or in this case, this derived class will inherit the properties of all the base classes, both of these two. And in this case, it will inherit properties of this, this, and this. That's why it is all. And derived class may add data members of its own. It may have some of its own also. Member functions or methods also, the derived class inherits all the member functions of all the base classes. That is obvious. And derived class may overwrite inherited function of any base class. Okay. And may overload also any base class. So the thing is, whatever it inherits, no matter it is inheriting from this immediate base class or higher above base class, it can override or overload. There is no restriction for that. Okay. And derived class definitely can add some methods. So member class specifications, although inherited, derived class cannot access private members of any base class. So this is not possible. Okay. So if anything that is derived private in any of the base class, that is, so private members cannot be inherited, that we all know. So that is quite trivial. And derived class can access protected data members of any base class. So these are trivial points, just to let us note these points. And regarding constructor destructors, what do you think if you try to construct an object of this type? So you know that there are if I get back to this, so if I would like to say, even in this case, so I would like to construct the black object. So which color should be constructed first? What do you think? Blue, then green, then red, then black. So which portions should be constructed first, or which classes should be constructed first? Are you getting the question?
No, sir. Can you repeat that?
See, the dean object means this black object, the whole black portion. It is comprised of some admin part, that means this red part, some faculty part, that is the green part, and it also contains some employee, some of this topmost base part, root base, this employee part. There is a blue part, right? Now, when you are trying to construct this black box, so in which order these colors should be constructed, or this, in other words, the constructor should be called. So to call the dean class constructor, before this constructor gets executed, you would expect these portions or these constructors to be invoked, right? And before these two gets invoked, you would expect the employee constructor should be invoked. So in which order do you think the constructor should be invoked? Is the question clear?
First blue,
Hmm?
first blue, then green or uh, which green or red, then
So
black.
yes, so first blue, that is confirmed. So because you know that even in the blue part you should have a I mean even in the red part you should have a blue, and even in the green part you should have a say blue, so that is fine. But what about this, whether it is red first or green first? How to resolve? Which one do you think should be preferred? And how you know the preference? How the compiler knows? Any idea from when you write the class definition, from the definition itself, can you resolve which order it should be done? You are specifying the base class names by separated by commas, right?
Yes, sir.
So can we stick to this or that order? That is quite obvious, because you are telling that the dean class should be inherited from the faculty class. So you specify the faculty class name first, and then you go for the admin class name. So maybe the faculty. So what is the faculty? The green part should be constructed, and then the admin class part should be constructed. I mean, and even before that, maybe the blue. So the blue part, and then this, then this. I mean the blue part, then this, and then the dean part, right? So this constructor first calls all the base classes, definitely all the base constructors, to construct the base class instance with it. And in which order they will be constructed? The base class constructors are called in the listing order. Do you agree with this term? Listing order means in the order in which you list or write them separated by commas. That is called a listing order. Is that okay?
Yes, sir.
And in which order you would expect them to be destroyed, or the destructors to be called, when the object instance gets destroyed, a base I mean a derived object?
Reverse of the listing.
So it is called derived class destructor is called first. So definitely the derived class, because that was the last one which got constructed, so that will be destructed first, followed by all the base class destructors in the reverse order of construction. Is that fine? So these we call it as a semantics of this multiple inheritance. Semantics means, so what you really can do when you inherit, and which one you can inherit, what you are free to, if you are free to modify or not, and all these details. So this in a nutshell, I mean it talks about all the kind of rules that you should follow during, or that the say compiler follows during this construction and the derivation. So these are some examples, simple examples, just to have a more concrete understanding of what we just now explained. So the whole story has been explained already. So just let us see some examples to see that, okay, this is what I meant, right? So this is class B1 and this class B2, and you see D is derived from B1 and B2 publicly. So this is B1 and this is B2 and this is D getting inherited publicly. So it's a ISA, okay. So this means, so this is what it means. Right? And what we have got B1 here, we have got B2 here, and we have got public B1. So there is, you see, there's B1 in the object X layout, you have got B1 and B, and in the object Y also you have got B2. That is fine. So B1, B2 you can distinguish, but it has got another variable named the same. So here is this B1 and this B1 might create conflict when you construct a object type D. Okay. So definitely in this object type D, it inherits all the members of B1 and B2. And what it does, so it inherits B1B and B2B. And it also says that it adds a new member D1. So this is D1. This is the black portion that we are talking about, right? So we are talking about an exact implementation of our discussion there. I mean, using colors that I just explained. Now you see we have got X, Y, and D. Instance of, so X belongs to object of B1, Y belongs to object of B2, and D belongs to object of D. Okay. Now what I write here, d dot d2, will it work? First of all, d dot d2, d sorry, d dot d1, d dot d1, is there any issue here? If I try to display the value of d dot d1,
No, sir.
No, sir.
it's simple because it has got, without any ambiguity, it is an exclusive data member defined by the derived class, in the derived class. So this access works. However, the value is unknown as uninitialized. So we cannot show what value it is there in the output because we have not initialized it intentionally, but it is accessible, right? But now if I write cout d dot b, d dot b, now the problem occurs, the one that we are hinting at. So d dot b means which b? You have got this b and this b. So which b? Error. So it will display this message, error, request for a member b is ambiguous, right? Why? Because the candidates are b's d and b2's, b1's d and b2's d. Now is there some way of resolving this? Simply writing it, it is ambiguous because I know in the object d's layout you have got two different b's, but I know that this is b1's b and this is b2's b. So this is possible if I specify d dot b1 colon b and d dot b2 colon b, then this access works. Okay. However, again the value is unknown, but this way you can resolve the ambiguity. Are you getting the point? So the thing is, while you construct the object d, there is no error because the construction is allowed by the compiler. The compiler says it's up to you, but you should be aware that you are unnecessarily creating an ambiguity, and the ambiguity, because you have created the ambiguity, it is your responsibility to resolve it also, and you can resolve it by specifying the class name colon the ambiguous data member's name. Okay, so the compiler says that I can't help you. If you resolve it, I'll display it. Otherwise, it's up to you. I'll give an error message. So the derived class C++ does not guarantee relative, and this is important. So C++ does not guarantee the relative positions of the base instances. So what I mean to say is, so whether this B1 will be, now the construction order will be B1 and B2. The constructors of B1 and B2 will be invoked. That is fine. But during the placement in that object layout, whether these B1's members will come first or B2's will come first, that is not guaranteed. Okay. And the ambiguities occur, and you can resolve it by specifying the base class name. Is that clear?
Yes, sir.
So this is just a simple modification. Instead of trying to talk about data members, we are now talking about member functions, right? Member data instead of that. So now I have used the same B1 and B2, and D is the derived one. And instead of dealing with, so you see we don't have any data members at all, but we are full of, we are dealing with member functions, and try to see how and if the same way we can resolve the ambiguity while invoke the methods. So we have got, you see here we have got fx, then gx, then we have got hx. Okay, and in this b1 and in this b2 also we have got fx, gx, hx, right? And in this d, which is publicly derived from b1 and b2, what we did, we have got gx overridden. So gx we are writing something, hx we are writing something, and we are adding kx. So kx is a completely new one. We have added this one. So these two are inherited but overridden. So it has been inherited from both sides. Okay. So anyway you are inheriting. Now you have decided to, override this gx, hx, and kx you are just adding. But what about fx? fx there is no mention here, right? So it inherits b1's fx and b2's fx. Okay. And what is the difference between these two? You see, b1's fx is got integer argument, and b2's fx it has got void argument. Okay. So they are having different. So it's basically overloaded. I mean, they two are different in terms of the arguments that they accept. So if I write here D, if I create an object of type D like this, okay. Now object D invokes D dot fx, D dot fx 4. What do you think? What should be the case? D dot fx 4.
Sir, of class B1 function fx will implement.
Now see, the point is, if I ignore this statement, so in this statement I should have eliminated it first. So if I am not having this, and in that situation if you call this d colon d dot fx 4, now you know that okay, d dot fx 4 means I have inherited both the fx, but it accepts integer and it accepts void, right? So even though I have got both the same function names, which has not been overridden here or overloaded here, and if I call fx 4, so there is no ambiguity and you should be calling this one, right?
Yes,
but if you simply write this, it will give an error message. It will be error message request for a member fx ambiguous, cannot resolve. So it stops, or the compiler, although it seems that it should have worked, but it will not allow such things to happen. Rather, it says that if you have inherited the same name, the function with the same name from both the base classes in your case, and you have chosen not to override or overload that in your own way, and if you're still trying to call that or invoke that method, this is ambiguity that I treat. And but you have the option to specify that which one should I actually consider. So if I write here using b1 colon fx, that means you are hiding, you say explicitly say that I would like to choose this one whenever I call, and I hide this one. Okay, so choose this one means by default if you write d dot fx, so d dot fx means that means by default I am accepting this one. So I am accepting this one fx int, I am accepting this one. But if I would like to call, because this also got inherited and it has got a different signature, there is no ambiguity. So if you would like to call this, you can call this, but you have to be explicit. You have to write d dot b2's fx. Only then I will allow you. So that is how the compiler deals with in this situation. Is that part clear?
Yes, sir.
sir, means the first d dot fx for the class B1 function will execute, no?
Yes, it's definitely, because this is the only option where it is. That's why it is showing this one.
For that we have to write that using B1
Using it.
scope resolution fx.
Yes. So this means, see, you can always write the scope resolution, but the thing is, see, even if you don't write the scope resolution, it is automatically selecting this copy, because you say using means your preference you give. So it's just like you have got both, but you have got a soft preference over that. Okay.
Yes, sir.
So that is what it means. But does not mean that fx void cannot be accessed, because simply because fx int and fx void you can distinguish, the compiler can distinguish. So it can do, but you have to be explicitly mention the You have to explicitly mention the base class names to resolve the ambiguity, and that is how the compiler deals with it. So the thing is, explicit use of the base class name can resolve the problem. However, it's a weak solution. I mean, it is not recommended. So this way it is probably not recommended, but still if you, so the design should be, so in terms of the design, this is not recommended. It's not a good, say maybe coding style. But if you still want to stick to this, this is the way you can resolve. Rather, you should explicitly disambiguate. So what it says, in this case, you can write d dot b1 fx4 and d dot b2 fx4, but this is not recommended. Rather, you should explicitly disambiguate the ambiguous functions by writing a redefinition. Okay, so it's better to redefine and do it like that, or by using the keyword you can resolve it. So the basic problem of say multiple inheritance, of resolving the call to a method with this, which is bearing the same name, or to a member which is bearing the same name in both the base classes, we found out how to do it by specifying the base class name with the scope resolution, right? So the first problem that we identified, so this first problem, this problem got resolved, right? Hello, so is that part done? Any question?
No, sir.
Okay, so I think it's almost more than an hour, so it will not take too much time. So let me just complete. There are 2 slides only. These 2 slides are there because we have already discussed about the case. Let us see the solution. So now we see the solution, or the how we resolve the ambiguity of the diamond problem. So what is the diamond problem? This is A. You see, this is A, this is B1, this is B2, and this is D, corresponding to this particular example. Okay, so we found this, and you see there is a data member A, there is a data member B1, there is a data member B2, and there is a data member D here. Okay, so it has defined here A, this is B1, this is B2, and this is D. But because of public mode of inheritance, you see this is available here, this is available here, and this in turn is available here, here, and here. Okay, so effectively in the D, in this D's layout, you see it has got this D, this is this part, it has got see, when it publicly inherits from B1 and B2, it has got the this base class portion and this base class portion. Okay, and when you would like to construct, you see we are explicitly writing the constructor here to see the issue. So when you are constructing D, this whole object, you have to pass on values corresponding to, say, maybe you have to pass on values that will fit in here, you have to pass on values that will fit in here, you have to here, and this, this portion, the base portion, the blue portion. Okay, so that's why I decided to accept 4 arguments, but I have set the default values also. So these are constructor with default arguments. Now you see here it is public B, public B, public B1, public B2, and public B1 says that when you are trying to construct me, I'll construct the public A, I mean the class A, and I'll construct the class A. So here when you are writing this, you see, when you are writing this, you are trying to construct this B2, say B2 and B1 and D, D of R. So up to this, is this clear? So what I'm trying to do here, taking these values, when you construct this object T of derived type, because it has got default arguments, now I am trying to, before I construct the this this bigger one, I mean, or this portion of the exclusive to the derived object, I would like to construct the base portions, this part, this part. So I have passed Q to construct B2, and I have passed P to construct B1, right? And I have passed R to construct the exclusive derived portion. Now when this B2 is called, B2 means B2's constructor is called, it will construct, and it will, now you see what has happened here. So B2 will pass the same value in A and this, so both. So it basically copying the same, and B1 is also copying the same, and D1, like this. Okay. And within this constructor, if we, so after initializing all the values, if I would like to refer to B1, B2 and D, this will work. So D means this one, B1 is this one, B2 is this one. But if I like to refer to A, then there is a problem. Got the problem? So the same that we talked about. What is A? Now here in the constructor, because everything has been constructed and initialized also, so in the constructor, if you would like to just display the values that has been initialized, if you write A, then A means it is difficult to resolve, because through the this pointer, you see this is a pointer, so through the this pointer you cannot resolve A. You say that whose A you are talking about, so it will not work. But this construction will be supported. I mean, this construction will work, and if you would like to refer to A, it says that it is ambiguous. So you probably will not be able to use these portions. And then if you write here, you see, if you upcast it, so through the upcasting using this P, which is a pointer to A, like P is up, pointer to this topmost class A, where you can only access to this blue portion, but this blue portion is ambiguous here in D. So this dynamically created object D, if you assign its address to P, you cannot really access this using this P, right? Because it is overall, after all, ambiguous. Got the point? Is that clear?
Yes, sir.
So this, I am not reading it once again. So the object T contains two sub-objects of A and all this, and A reference to D. So these are, so without diamonds, multiple inheritance is quite straightforward, as we just found earlier in the previous slides. But as soon as a diamond appears, trouble starts, because you have duplicate sub-objects of your new class in your new class, right? And this introduces ambiguities. So you just see syntactically how we face these things, and this is what the virtual inheritance means. Again, the keyword virtual helps us to resolve the problem. So the only trick that we need to make is tag this as virtual and tag this as virtual. So earlier it was everything same, you just put the keyword virtual here and insert the keyword virtual here. That means you say that whenever you are inheriting this portion, I mean this portion from this base class, it should be done virtually. Okay. So this virtual means if I do this, so this becomes a virtual base class. Okay, it's not an abstract base, it's a virtual base class, and this is also a virtual base class. And if I do so, then with the same thing here, you see, so this means this is virtual base class, means when you are constructing this derived object, look into it, if you are constructing this derived object, then earlier you used to construct the base portions, and this base portions would have constructed the root base portions like that, right? But in doing so, you created ambiguities. Now you say that I have tagged this as virtual. So when you are constructing the base portion, you are constructing only the exclusive base portions, right? So when you have constructed, you see B2, again you are passing Q, B1 you are passing P, and they are constructing only this part, but not the blue part. Can you see the difference? Can you see the difference? So the thing is, virtual keyword says that I should not construct the common portion of this. So that virtual keyword will resolve that. it will intelligently know that okay, that part need not be done. So when you are constructing, in this case, you see the problem. I mean, problem is the issue here. When B2 is constructed and B1 is constructed, only these portions are constructed. So now, who is going to construct the blue portion? As in the previous case, your immediate base classes is not constructing the root base portions. So who is going to take care of that? Hello?
These constructors are.
Are you getting my? Are you getting the problem? So the derived class itself calls A of S. A of S means it is directly trying to construct the base portion. So it says that let me take care of it. Because of this ambiguity, let me take care of the construction of the blue part exclusively. Okay. And when I call these two, it says that okay, you construct your exclusive part and no need to bother about the common base part. I'll take care of it. So you see the difference here. Is there any call to construct the root base portion here? Can you see the difference? Hello? Can you follow
Yes.
me?
Yes, sir.
So it exclusively, so because of this ambiguity, it says that okay, let me tag it as virtual. So this virtual will enable the creation of the base portions, exclusive portions, and the common portion need not be done. I mean, will not be done, and we'll do it. The derived class itself says that okay, I'll do it. Okay. So once this is done, then you can automatically you can refer to A because you now have unambiguous single copy of A like that. And if you are having that, then you can freely or quite nicely go for upcasting. And here the problem is this upcasting will not be allowed. Forget about referring, but the thing is this upcasting also will not be allowed. So this is an error message. What the point? Because if you upcast, what should you do? Because whatever you want to do, it has been duplicated. It was unambiguous. But here it is. There is no harm. There is no problem, and you can now refer to it. If you want, you can refer. If you don't, you can may not like that. But this is allowed. Okay. So the solution is the prefix. We add a prefix to every inheritance of A with virtual to inherit a base class as virtual, so that only one sub-object of that class will ever appear as a base class in the object derived from it. When you are using a virtual base class, the most derived constructor, that is the one currently you are most derived means the bottommost one, is responsible for initializing that virtual base class. That is what is done here, you see. This means any class, no matter how far it is from the virtual base, is responsible for initializing it. So if you think of a hierarchy something like this, okay. So this should be written as virtual public A, virtual public A, virtual public D, virtual, so like that. And who is going to create this base instance? When you are creating some object, say age, corresponding to this derived class, who is going to construct this portion of A? The most derived constructor. That means this age. I mean the age constructor should be calling A of something. Is that part clear?
Yes, sir.
Okay. So it's almost done. So dealing with ambiguous functions. So if you have got ambiguity in the function calls, then we can, I mean, till now, you see, we have not mentioned any of these functions as virtual. So now you see that this is a virtual inheritance, example of virtual inheritance here. To avoid the problem due to diamond structure, as well as we have got virtual functions. I mean, it's a polymorphic class also. We have got virtual functions where the virtual keyword has been tagged here like this. So because we have got a virtual inheritance here, this upcasting is allowed even in case of multiple and diamond shape inheritance. And if I write p colon PROFN, because this it's a virtual function, it goes for dynamic dispatch, and it rightly chooses to invoke D's FN. Okay, so that much for this class. Do you have any questions?
No, sir.
So we are almost done with the this part. This inheritance and dynamic binding, multiple inheritance and all. So one small topic is left regarding it's a debatable design issue, and regarding which kind of design you prefer. Do you prefer multiple inheritance, or because you know that there are so many ambiguities and all this you have to resolve and all this, so do you still want to stick to this kind of design where the overall design still uses multiple inheritance, or you try to go for an alternative design where we try to completely avoid multiple inheritance in some sense? So that is just one point that I discuss in the next class, and that will end our discussion on this inheritance and the different problems that arises out of it. And we all know that inheritance is one of a very important feature in this object-oriented design, and it may be C++ or maybe Java or whatever, but this is a very important concept, and how we apply this in our design and how we implement it in a language syntax, and what are the hidden issues that arises out of it. I think you have got a fair amount of idea about this. So there will be some, I think there's some of them are already given some assignments on this. So if you solve one or two of them, then at least you will get a feel of the syntax errors and all this, or the concepts that I explained. You'll be able to utilize that. So in the next class, I'll be talking about templates. After having a very small discussion on that design issue, or the debate on that, I'll be starting the templates. And the templates, it will take another maybe just 2 lectures. It's not.
Sir, so we don't have to do the number 6 question of assignment 6, right? Because it had templates in itself.
No, you may just hold it on, because once the templates are there, you can easily implement it. So just for the timing, you can ignore that.
Okay, sir.
Because actually, I set this assignments in anticipation that I thought of teaching, covering these templates before I took that leave, but it didn't happen actually. So that is the reason. And when Dipanita uploaded it, he didn't detect that, or he was not aware of that. So that was the main reason. And I set the assignments, but she uploaded it. Anyway, that is not a big problem. You can ignore it and upload the assignments.
Okay, sir.
Any question?
No, sir.
Okay, your exam dates, I think those are fixed. Have you got any notification from the academic section?
Sir, not yet, sir.
Yes, I think today the Senate has confirmed that. The Senate has accepted in the today's Senate meeting. So I think the official notification will be uh, published very soon. That is from 3rd to 8th. The first week of April. That 3rd to 8th. So your end sem exams will be there. So we'll have another at least 1 week time, and that is good enough for the templates, to complete the templates.
Sir, I have a question.
Hmm.
Sir, in diamond problem, like class B and C are inherited from A and D is
Hmm.
inherited from B and C. If there is a
Hmm.
class above A, then
Hmm.
whether A class will be virtual or not?
Whether A class will be virtual.
Yes, sir.
No, A
Sir,
class. So the class A may not. So if you have got some other X above A, so that is straightforward. That may not be virtual. But then whenever you take multiple roots from a particular base class to reach another descendant class, there you need to go for a virtualization. I mean that there you have to specify virtual keyword.
okay, sir. And sir, do we need to change the
I mean,
construct?
see,
Yes, sir.
you feel it in a simple way that if you are constructing A, and while you are constructing A, if A constructs the portion of X, will there be any problem?
No, sir.
So then there is no need to complicate things, right? So it can do that. But if you allow D, I mean B and C to construct A, then there is a problem. They create their individual copies, and it creates a mess out of it. But if A has got X on the top, so it can easily construct. So when you ask that, okay, you construct A in turn constructs X, and that's done.
Okay, sir.
Hmm. Anything else?
Sir, one question, sir. Sir, what will be the format for the NSEM exams?
See, again, it's a very hard question to answer because we have not decided it yet. And in the meeting also, UGSC, I mean undergraduate academic studies, that meeting also they didn't come up with any guidelines, and I don't think so that they will come up with any guidelines. But you see, it's a 3 hour exam, and 3 hour exam full of um objective questions. If you really want to keep students busy, probably we have to set, say, at least how many, I don't know, it depends on the uh, difficulty level of that, but it will be too many of them. And I can still go for relative marking to have a huge pool of questions from which you actually choose and they come. That can be one option. Other option can be part of the questions will be objective type and the rest will be subjective type. But that guideline, it was explicit guideline was given in the previous semester that you should go for subjective questions also. But this time there is no such clear guidelines. So let me discuss about with my other colleagues who are taking the course. But as such, the faculties are free to set whatever pattern they feel like. There is no constraints. And specifically for this object-oriented programming, I would prefer to have some design like coding portions. Definitely, I do not like to set questions on what is polymorphism, what is inheritance. Those are really uh, a school-like questions, school-level questions. So there may be some codings, coding-based questions given, and maybe too many numbers, because say for 60 you may have a question paper set for total. If you want to score the marks or attempt the marks, it can be 100 marks questions, and based on the highest marks that will be scaled down to 60, and accordingly other marks will be mapped. So that what I have planned.
Sir, actually, that format, sir, it becomes very lengthy for us, sir, to do it in that, like, that's what happened in CA2, sir. It was very lengthy, the paper.
No, I mean,
There's a lot of time.
I think you are not getting my point. So what I mean to say is, even if I set a 300 marks questions, what is your problem? So the fact is, you may have, or maybe the some of your friends, whoever is, hypothetically, say for example, he might have succeeded to answer, say, 250 or score 250 marks, right? So logically it means that everybody should have answered up to that level because it is feasible. That means what it means. So it doesn't matter how many, what is the total marks. What it matters is what is the highest marks that the student scored in the entire batch, and it might be 30 also. Nobody knows.
Okay, sir. Got
So
it. Sir.
30 will be mapped to 60. So does it really matter how much is the total number of total marks, or how many questions do I set? Rather, you
No,
should be
sir.
happy that as long as you have time, you keep on answering instead of helping your friends out, right? So
Yes, sir.
yeah, we all know that what goes on. I mean, this is a human tendency that in the exams, if you have got options, you try to take help and all. But this in this situation, I mean, many things we have to accept, and you also are accepting, and let's try to have the best out of it rather than indulging on those activities. So that's a reason why I opt for it.
And sir, what will be the format for the sessional, sir, exam,
Sessional,
sir?
sessional definitely there will be a maybe a 45 minutes time will be given, and a question and the program you have to solve.
Okay, sir.
Okay,
Okay,
so
sir.
that will be a bit straightforward, and I don't like to take Viva Voci. That is, it's not possible for all these 200 students. So maybe one question, and based on your assignments and your the timing when you submitted assignments and all this, we'll be giving some. So
Sir,
definitely the variance of the marks will be too less these days, but that we all have to accept. And whether you learn or whether you intend to learn, it's up to you, because marks really, uh, when you join industries or when you join research or you join academics later on, you'll find that marks really hardly matters. But to be more practical, you really need marks at least to bootstrap your career, right? So I mean, whether you would be like to be honest, or whether you'd like to at least try to get things, or you try to rely on getting help on from your friends, it's up to you. So uh, marks or those figures does not make a lot of impact later on, apart from these 4 years. So even though you manage somehow, I think the best thing is at least during the courses. I know that it's a like this kind of distant learning is, it's not good, but still you should try to learn the concepts and apply the concepts. And if you have got questions, maybe wild questions, you can ask. I can try to answer. Uh, so that is the best thing that we can do. But sessional will be bit straightforward. Just one question, maybe 45 minutes, 30 minutes. That will depend on the type of question that is set. You should be solving it, and maybe a screenshot of that code and the output. You can save it as a PDF and send it. Anything else?
No, sir. Sir, you also told us to remind you at the end of the class to send the
Yes, yes.
selected.
I'll do it right now.
Yeah.
Within 5 minutes. I'll do it.
Thank you, sir. Thank you so much, sir.
Okay. Thank you.